Welcome to Unacademy, the number one learning app in India that made learning easy for all the students. So now you can sit back at your home and you can listen to the class at the fingertip, right? So before going for the session, I will give a small introduction regarding our Unacademy Plus program for Karnataka CET 2021 completive batches, and it's live on Unacademy. Like we have different beneficiaries, like complete syllabus will be covered, tips and tricks given by the top educators from the part of Karnataka, topic wise practice questions, full length mock test. So these are the beneficiaries we give for the students, and 1 month plan at 2500, and it is available till 30th of January, and it is only for new subscribers, and you can use my code, that is RITESHLIVE, so that you can get a 10% of instant discount over the plus subscriptions. Okay, so this is the code for getting 10% of discount, and even you can go through this link for getting or for the what uh, for to know more regarding our plus program. Okay, so before going for the session, okay, I have informed regarding our unacademy plus. And okay, one more thing, like we have different plans, like 1 month plan, 6 month plan, and 12 month plan. So you can recommend your plus one friends also, so that they can join unacademy plus program. So we have 24 month of plan for the students. See, a 1 month plan, as I told, 2500, and 6 month plan at 11,250 rupees, and 12 month plan at 13,750 rupees. Okay, the beneficiaries, like premium content at affordable price, structured live courses, dedicated live doubt clearing sessions, quizzes at regular interval, batches for the complete preparation, test series, and a lot more things. Okay, yes, today's session is all about refraction and total internal reflection. Okay, so we are at the end of the reflection concept, right? In yesterday's session, we had a mirror equation, and for one or two joiners who asked me to repeat the things, so I have repeated yesterday's class. So we lagged a little bit. So I will go faster in this session. So hope the joiners will join as soon as possible, and please make full use of that comment box. You can ask the doubts regarding the concept what I am teaching, so that I will clarify the um, doubts, confusions, whatever the things you have um, in terms of the what subject. Okay, yes. Oh, this is our first lecture. We had all the concepts. So what I do is I will directly go for the things which are okay. Refraction. So before refraction, okay, this is the magnification. Okay, done. We were in the magnification. What do you mean by magnification, my dears? Magnification is nothing but it will give a exact picture of image height and the object height. So what is image height? What is object height? So I have told you, like, see, every mirror will project the image. That image height will be what, maybe larger, or maybe enlarged, maybe, or maybe what smaller, that is comparing to the mirror. Okay, whether it may be convex mirror, concave mirror, depending upon the mirror and the design of that mirror, the image height will be vary, right? So the relation we will find for that image height and object height. Hi, good evening Ganita, thank you for joining. So yes, everything, focus point, center of curvature, pole, then focal length, object distance, image distance, everything regarding that, right? So I will directly go for the derivation. See here, this is the object height which is placed first. So let me take an object of A to B, AB height. Okay, so I denote it by as H naught. Okay, the object is placed at a distance of U. Always the object distance is given by the term U, that is for object, right? Similarly for the image is nothing but V, the image distance. Okay, so here where the image is found, the any minimum two rays should follow from an object to get the image of any object, right? So I have taken one ray which will follow parallel to this principal axis. Okay, then it will reflect back in such a way that it will pass through the focus point. Okay, anyhow, every rays which is parallel to the principal axis will reflect back in such a way that it will pass through the focus point. Okay, that is the rule number one. Then another ray which will follow from here, that will go and hit a strike over the midpoint of the mirror, and it will reflect back in such a way that incident angle, that is theta, that is also equal to reflected angle, right, theta r. So I have taken theta, both are equal, that is the rule number 2. Okay, so those two reflected rays and rays will come and meet at a single point. That the point is nothing but image height of the object. Okay, that is hi. So this is how the what a figure, right? So let me go for the sorting out, for the derivation. Let me give the relationship for the magnification. So I will consider first triangle, that is ABP. So which is the ABP? See here, triangle number 1, right angle triangle ABP, right? Okay, sorry, like this. Done. Oh, okay. I will erase this. Yes, super. So ABP, see you in this triangle. Consider, you have to consider such a way that this H naught term should come. For that sake, I will take tan theta. So I have taken tan theta. Tan theta is nothing but opposite. Which is opposite? It is the opposite divided by adjacent. So adjacent is nothing but B to P. So that is image, not image, object distance, right? Okay, that is the one equation I got. Similarly, I go for another triangle B dash A dash and P. Here also the angle theta. Then the same equation, that is opposite over adjacent, that is nothing but HI over V. Okay, now I got two equations, my dears. Yes, equation number 2, same thing. Now from equation number 1 and equation number 2, what I do is I will divide, so that I will get a new equation, that is AB over U is equal to A dash B dash over V, right? So now tell me, AB is nothing but H naught, right? Not AB dash. Okay, AB dash is nothing but HI, and AB is nothing but H naught. Okay, that is nothing but magnification. So magnification relation, I got HI over H naught, that is equal to V over U. This is the equation. We are not over it. Why? Because you have to apply the what sine rule, right? Which is the sine rule? Along the direction of incident ray, you have to take positive, and opposite to that negative. Principal axis, or above the principal axis positive, below the principal axis negative. So HI, which is HI is below the principal axis. I have taken negative. Is it right? Yes, good. And above the principal axis, I have taken positive, H naught. And similarly, V, that is opposite to the incident ray. See, this is the incident ray, and distance measured from the pole to here, that is negative. Similarly for object and image distance, right? Now after rearranging, I got hi over h naught, that is equal to minus v over u. So this is the relation, my dears. So you have to be keep it in your mind, and you have to practice for deriving equation for magnification. Okay, magnification is nothing but minus v over u. V is nothing but image distance, and u is nothing but object distance. And for the 1 mark question for KCET, okay, for KCET, magnification, when magnification is negative, minus, the object is real and inverted. Okay, this is the inverted image. Inverted image is nothing but ulta. Okay, so actual object are see here. So actual object height is from A to B. A is at the top, right? B is at the down. But when you compare here, B is at the top, A is at the down. So that is nothing but inverted. Okay, and it is real. Real means from the reflected ray you got the image, and this image is real. But for positive, that is virtual and erect. Erect means as same as this. That is possible only by the refraction. Okay, so what is refraction? Everything we will study later. Okay, so okay, done. So when magnification positive, then it is virtual and erect. Okay, so you can keep it in your mind by using this MNR MPV. Okay, so hope you understood, right? Okay, if you have doubts regarding, please comment there. Okay, I will help you out to sort out the confusions regarding. No doubt, paka. Two members are live. Okay, so no doubts, right? Okay, I will go for next, refraction. Refraction is nothing but key point. Definition, law of refraction, refraction index, very important term, neta. Okay, then real depth, virtual depth, and relations. So okay. So what is refraction? Refraction is nothing but example I will give first. If you have a glass of water, you will insert a pen over it. Okay, you will insert a pen into it. So the pen will look like somewhat bent, right? Bent ಆದ ತರ ಕಾಣ್ತದೆ. ಯಾಕೆ? Due to the refraction. Is it right? Yes, my dear. So if you have a glass of water with the full of water, whatever, then you will insert a stick or whatever, then that stick will look like somewhat bent. Is it right? That is due to the refraction. Okay, so let me give the definition of it. Refraction is nothing but when a ray travels from one medium to another medium, the which is the one medium here. Air is the first medium and water is the second medium. When a ray of light, when a ray travels from one medium to another medium, the part of it is reflected and back, and the rest of will enter into the another medium. So okay, this is the what entered what ray. Okay, also it changes its direction. For that sake it will look like a bent. This phenomenon is refraction, see here. But this is the incident ray and this is the refracted ray. See here, it is bent. Actual path is like this, but it bent. Okay, so this is the normal line, and observe here, it bent towards the normal line. One ray moving from a rare medium, that is air, to denser medium. Denser medium is whatever, glass or water. Okay, see, this concept you need to keep it in mind. Like when a ray of light entering from air medium to denser medium, the ray of light will move towards the normal line. Hope you understood, right? Okay, let me go for next. Law of refraction. Law of refraction is nothing but the incident ray, refracted ray, and normal line all should lie on the same plane. Yes, of course. So this is the plane, and this is the normal line, this is the incident ray, and this is the refracted ray. This is the angle of incident, and this is the angle of refraction, and this is the plane. Okay, done. Next one, a rule: the ratio of sine of incident angle theta I to the sine of refracted angle is always a constant. So the ratio of incident angle theta I over theta R, that is always a constant. So that is nothing but, okay, they have given sine of incident. You need to keep it in mind. Sine theta I, sine R, that is constant. That is nothing but a refractive index. A very important term in this refraction. Okay, sine I over sine R, that is neta. Okay, that is the second rule, a concept. Okay, then we go for what is refraction index. Refraction index definition is nothing but it will give the exact relationship between the different medium. Okay, so how ray of light will move in air media, how it will move in water media. See, in the ray of light will move in air media with a high speed, but when it come to a water media, the ray of light will come slower. Why? Because due to the refraction, there is obstacles will be more for the ray of light. Therefore, that sake, the movement of the ray inside the water will be slow. Okay, so the optically refractive index of the air is 1, refractive index of the water is 1.3, and glass is 1.45. Then for the diamond it is 2.3, I guess. So these are the different refractive index. So how they calculate refractive index? That is nothing but a neta, a refractive index, that is C over V. C is nothing but velocity of light, and V is nothing but velocity of the light in the medium. Okay, which are the medium? So here, for air medium, velocity of light is same. In the same speed, the velocity of light. Okay, air medium is nothing but velocity of light in vacuum air, that is 3 into 10 to the power 8, and for the speed of light in the medium, that is air only, when it is in air, 3 into 10 to the power 8, then you will get refractive index 1. Okay, hope you understood. Similarly, they will go for glass and other thing. So for glass, that is C is constant, 3 into 10 to the power 8, and here it will be slower. I mean, the speed of the light will be slow in water, maybe around 2 into 10 to the power 8 or whatever, 2.5 something. Then you will get, see how much you will get, 1.3 something you will get, like that. Okay, so this is dependent. Okay, water, okay, in the water no dependent, it is constant also, it has some value. Similarly for the glass, 1.5. Okay, so these are the different values of neta, that is nothing but a refractive index of different medium. Okay, so hope you understood, my dears. Right, so if you have any doubts regarding, please ask me. So please, before leaving, hit the like button there if you understood the concept, and even you can comment in the chat box, so I will clarify the doubts regarding. Okay, and even subscribe for an academy channel, and please leave a like button there before leaving, only if you understood the concept, and only if you uh, like the notes which I have prepared here. Okay, so you can download the PDF also later. Then numerical problem. Okay, before going for the numerical, there is a KCET very important formula, that is neta is equal to real depth over apparent depth. Okay, so what is a real depth? Neta can be find real depth over apparent depth. Okay, no derivation for this, but for KCET, I have given this apparent depth. Okay, so what is real depth? The real depth is actual depth of the whatever the metal or coin. Apparent depth is nothing but how it look like. So ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಇವಾಗ ಇಲ್ಲೊಂದು ಟಬ್ ಇದ್ರೆ, ಟಬ್ ಅಲ್ಲಿ you have full of water, then there is a coin inside the tub, but actual depth ಅದು ಒಳಗಡೆ ಇರುತ್ತೆ ತುಂಬಾ. But when you look from outside, for the eyesight, right, for the eyesight, it will look like very nearer, right? That is due to the refraction. If they ask in the exam, the phenomena of coin inside the glass looks like very nearer to the normal eye due to the phenomena of what? Reflection, refraction, TIR, whatever, total internal reflection, whatever. Okay, so actually the answer is refraction. Okay, so here a metal coin at the bottom of the beaker filled with the liquid of refractive index, how much they have given? 4 by 3. That is nothing but neta. So 4 by 3 they have given, at a height of 6 centimeter. The real depth is 6 centimeter. Now unit observer looking from above the surface of liquid, coin will appear at the depth of what? Yes, that apparent depth you need to find out. How much? Apparent depth is nothing but real depth. How much they have given? 6 divided by 4 by 3, that is 6 into 3 divided by 4. 2 3s are 2 2s are, you got a 9 by 2. How much? 4.5, I guess, right? 4.5 centimeter. The right answer is 4.5 centimeter. Option number 3. So for KCET, this type of question will arrive. So please concentrate. Hope you understood, my dears, right? Okay. So I go for next. Relationship between velocity of ray and the refractive index. How V and refractive index, neta, is related. For rare medium and denser medium. For rare medium, if you take this neta 1, we don't have any derivation. Neta 1, that is C over V1, anyhow you know. And dense medium, that is for water, and this is for air. Okay, then relating, you will get a new equation, neta 1 over neta 2, that is equal to V2 divided by V1. Neta 1 is nothing but a refractive index of air. Okay, so if they give you the velocity of velocity of light in air medium, water medium, then the refractive index of any medium, then you can find the other refractive index. Similarly for the velocities. Okay, so hope you understood, my dears, right? Done. Next, a relation between real depth and virtual depth. Already we got a relationship with image height and object height, right? So object height and image height. What is the equation, my dear? That is nothing but h I over h naught. That is equal to minus v over u. So this is the equation we derived already. But now the equation is, you need to find out the real depth and virtual depth. This is different. This is in the refraction unit. This is concept. This is in the reflection concept. Okay, don't make any confusion. Okay, so hope you understood. Yes, right. So we go for what relationship between real depth and the virtual depth. What do you mean by real depth? Real depth is nothing but the actual depth where the coin is placed. That is nothing but an object. And virtual depth is nothing but where that coin, where that object will look like from the outside world. That is from the air medium or the air medium. Alright? Okay, so when I see from eyes, naked eye, the coin will look like at a very nearer distance, right? So I will take that point as a C, and that distance is nothing but image height. Okay, object height actually is the actual height. Okay, object height h naught. So see here, these are the different terms I have given, and the incident angle is theta 1, and the uh, refracted angle is theta 2. So it will not be same. Theta is equal to theta. It will not be same. Incident and refracted angle will not be same in the case of what? Refraction. But it is same only in the reflection. Okay, now it is not same. I have taken theta 1, I have taken theta 2. So this is the normal line. Is it right? Okay, so actual path is like this, but you have to write the refracted ray that is towards the normal line, my dear. Okay, okay, done. So uh, the whole distance from here to here will be same, theta 1. Why? Because see here, this and this, like this. Okay, I mean like this. Okay, if this is t1, this also should be t1, theta 1, right? Okay, done. Let me erase that. Let me erase that. Let me erase that. Yes, super. So this is the figure we have. So now see here, and again I have taken here this as theta 1, that is from the alternative angle, right? Theta 1, and here it is theta 1, alternative angle, right? So theta 1, is it right? Okay, my dear. Hi Abhi, repeat this one again, please. Okay, so should I repeat the figure, my dear Abhinav? Should I repeat the figure? So hope you understood, right? Alternative angles, huh? Yes, alternative angles is nothing but, you know, right, from mathematics, alternative angle is nothing but if you have a angle of theta here, here also the angle will be same. Okay, for figure. Okay, my dear Abhinav, let me explain it again. So this is refraction. You need to find the relationship between real depth and virtual depth, right? Real depth, actually the real depth where the object is placed. Virtual depth is nothing but uh, if you place a coin inside the glass, it will look like very near to it, near to your eye from the outside world, right? So that is nothing but virtual depth, hi. So I will take that as C, point C. Real letter O, D. Okay, I have taken D, right? So the see the this is the incident angle, incident ray. So how the incident angle will be in this what refraction. This is the incident angle. Okay, this is the normal line, is it right? Actual path of incident angle should be like this. Okay, if there is no medium, no what plane, after the plane it will bend like this. Okay, that is nearer to the normal line always in the refraction. So this is a theta 1, and this is theta 2. Okay, theta 1, theta I incident or theta r. Okay, I have taken theta 1 and theta 2. Similarly, I have done here. So, hope you understood. Okay. Then, okay, theta 2 here. See here, again, this theta 1, that is equal to whole theta 1. Why? See here. Okay, from this. Similarly, alternative angle, from that I have written theta 1, that is equal to theta 1. This total is theta 1, and here it will be theta 1. So, hope you understood, Abhinav. Abhi, ಅರ್ಥ ಆಯ್ತಾ? ಅರ್ಥ ಆದ್ರೆ ಮಾತ್ರ ಮುಂದೆ ಹೋಗೋದು. ಇನ್ನು ಕನ್ಫ್ಯೂಷನ್ ಇದೆಯಾ ಏನಾದ್ರು? ಯಾವ ತರ ರೇಸ್ ಬರ್ತದೆ, ಯಾವ ತರ ಚೇಂಜ್ ಆಗ್ತದೆ ಅಂತ? ಎಸ್ ಸರ್, ಸೂಪರ್, ಗುಡ್. ಹಾಯ್ ಪ್ರಜ್ವಲ್, ಗುಡ್ ಈವ್ನಿಂಗ್. ಓಕೆ, ಸೂಪರ್. ಇಷ್ಟ ಅರ್ಥ ಆದ್ರೆ ಸಾಕು. Then we go for derivation directly. Okay, derivation simple step ನೋಡ್ಕೊಳ್ಳಿ ಎಷ್ಟು simple step ಅಲ್ಲಿ ಇದೆ. This is object height h0, this is the image height. Okay, no issues regarding that. So we have two triangles, my dears. Which are the two triangles? So I will consider triangle ABC first. This triangle. Okay, so you have to write the equation so that you need to get a hi value. So hi ಸಿಗ್ಲೇಬೇಕು. We are finding relationship between hi and h naught, right? So ಇದರದ್ದು ತೆಗೆದಾಗ tan theta 1, that is opposite. ಇದರ opposite ಯಾವುದು ಹೇಳಿ? AB, right? Okay, opposite over what? Adjacent. Adjacent ಯಾವುದು? ಈ ಕಡೆ AC. So I have written AB over AC. So AC is nothing but hi. Okay, I got an equation. Simple. So tan theta I can write it as theta 1 because angle of incidence is very less. Angle in the ray optics is very less. Okay, so theta 1. Similarly, I gone through second triangle, which is the second triangle, my dear. Okay, this is the second triangle. Is it right? Sorry. Yes, this is the second triangle. A, B, D. Yes, A, B, D I have taken. See here tan theta 2. Where is the theta 2 here? Theta 2. Yes, I have to take theta 2 here. Why theta 2? See alternative angle again like this. See here it is theta 2. Is it right, my dear? And similarly here you need to write theta 2. Alternative angle. Okay. So this is the theta 2. So theta 2 is nothing but opposite over adjacent. That is AB over H naught. Yes, super. I got two equations. Alright. So now what I do is from Snell's law anyhow you know, N2 over N1, that is neta is equal to sin theta, sorry, sin I sin R, right? So or else that is 2 to 1. Okay. So N2 over N1, neta 2 over neta 1, that is sin theta 1 over sin theta 2. So this I can write directly theta 1 over theta 2. Okay. So what I do is I will substitute these equations here. Okay. When I substitute these equations, then I will get a new equation, that is neta 2 over neta 1, that is equal to h naught over hi. So very simple derivation, my dear. See here in the NCERT textbook they have given around 2 to 3 pages, but I have derived in only 2 to 3 slides, but the slide is very small in size, right? ಚಿಕ್ಕದರಲ್ಲಿದೆ. ಸೊ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಇದಷ್ಟು ಇದರಲ್ಲಿ ಬರುವುದಿಲ್ಲ. ಸೊ ಇದನ್ನು ನೋಟ್ ಮಾಡ್ಕೊಳ್ಬಹುದು. ಓಕೆ, ಸೊ ಹೋಪ್ ಯು ಅಂಡರ್ಸ್ಟುಡ್. ನೀಟಾ 2 over ನೀಟಾ 1 that is equal to h naught over hi. Okay, so this applies only when observer in the rare medium. See here you are waving from a rare medium, that is air. Okay, but in case you are viewing from the denser medium, I mean fish. If a fish is viewing, fish is the eyesight. Okay, ಇವಾಗ ಈ ಮೀನು ನೋಡ್ತಿದೆ. ಸೊ ಇದು ಮೀನು ಅಂತ ಅನ್ಕೊಳ್ಳಿ, ಮೀನು ತರ ಇದೆಯಲ್ಲ. ಓಕೆ, ಸೊ ಮೀನು ಈಗ ಒಳಗಡೆ ಫಿಶ್ ನೋಡ್ತೀರಾ ಔಟ್ಸೈಡ್ ವರ್ಲ್ಡ್ ಅಲ್ಲಿ. ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಇವಾಗ ಹೊರಗಡೆ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಈಕ್ವೇಶನ್ ಚೇಂಜ್ ಆಗ್ತದೆ. ಓಕೆ, ಸೊ ಈಕ್ವೇಶನ್ ಯಾವ ತರ ಆಗ್ತದೆ ಇವಾಗ ವೆನ್ ಅಬ್ಸರ್ವ್ ಇನ್ ದ ಡೆನ್ಸರ್ ಮೀಡಿಯಂ. ಎಸ್, ಸೊ hi ಯಾವಾಗ ಜಾಸ್ತಿ ಆಗ್ತದೆ, hi ಅಂದ್ರೆ ಇಮೇಜ್ ಹೈಟ್ ಜಾಸ್ತಿ ಆಗ್ತದೆ, ಆಬ್ಜೆಕ್ಟ್ ಹೈಟ್ ಕಮ್ಮಿ ಆಗ್ತದೆ. ಐ ಮೀನ್ ಸೊ ಇಮೇಜ್ ಇವಾಗ ಇಲ್ಲಿ ಪ್ಲೇಸ್ ಆಗಿದ್ರೆ, ಬಟ್ ಇದ್ರದ್ದು ಫಿಶ್ ಐಸೈಟ್ಗೆ ಇಟ್ ವಿಲ್ ಲುಕ್ ಲೈಕ್ ವೆರಿ ಫಾರ್ ಲೈಕ್ ದಿಸ್. ಓಕೆ, ಸೊ ನೀವು ಸ್ವಿಮ್ ಮಾಡೋರಾಗಿದ್ರೆ, ಇಫ್ ಯು ನೋ ದ ಸ್ವಿಮ್, ದೆನ್ ನಾಳೆ ಸ್ವಿಮ್ಮಿಂಗ್ ಪೂಲ್ಗೆ ಡೈವ್ ಮಾಡಿ ಬ್ಲಿಂಕ್ ಯುವರ್ ಐ ಅಂಡ್ ಸಿ ದ ವರ್ಲ್ಡ್. ಇಟ್ ವಿಲ್ ಲುಕ್ ವೆರಿ ಫಾರ್ ಫ್ರಮ್ ಯು ಔಟ್ಸೈಡ್. ಓಕೆ, ಹಾಯ್ ತಶಿನ್, ಗುಡ್ ಈವ್ನಿಂಗ್. So that is how the real depth and virtual depth according to the rare medium and denser medium. Okay, so hope you understood. So you can draw and you can relate it. So when you draw it, see here, so this is the normal line. So this is the incident, that is a fish side. Okay, so actual it should move like this. Okay, but now the ray is moving away from the normal line. Okay, that is nothing but ray will move like this. Okay, when from denser to rare medium. Okay, so this is the concept which I will explain in the upcoming session. This is till here That's enough for you guys. Like you should know the concept. Like when you view the objects from the rare medium, I mean from the air or from the outside world, the object which is inside the glass or whatever the tub, you will look like very nearer to your eyesight. Okay. Similarly, it is vice versa when you are viewing from the denser medium. I mean when you are viewing from the inside the water. Okay. Then it will look like very far away from you. Actually, it is very nearer, but it will look like far away from you. Okay, that is how the real and virtual depth. Okay, so hope you understood. Hi, Princeton, Silvan, Cardoza. Good evening, Princeton. Thank you for joining. Yes, so this is how the relationship between a real depth and virtual depth. Okay, we had around two to three derivations, right, today. So hope you understood, my dears. Thank you. So thanks a lot for joining. And before leaving the session, please hit the like button there. Okay, so that I feel very happy, like so it's okay, my students got the concept, so I feel like that. So or else dislike the button, no issues if you didn't got the concept. Okay, don't do that. Okay, so I just made fun. Then you can use the code RITESHLIVE for subscribing, my dears, and you can get a 10% of instant discount over the plus subscription. You can follow my profile in Unacademy platform, that is RITHESHNM. I did all the concepts from ray optics, around 20 classes I have taken there from ray optics and wave optics with the simple notes and with the simple steps like this. Every notes you can download the PDF there. You can follow my profile there also. So thanks a lot for joining. Have a great time. Love you all. So I will wind up the session. Bye bye. See you again in tomorrow's session. Thank you. Good night.